pagkakataon para matuto. Muli, ako ang inyong teacher, si Teacher Royce, at hayaan nyo na gabayan kayo at tulungan upang gawin natin ang math ay maging madali lang. Simulan na natin! Ang pag-uusapan natin ngayon ay tungkol sa polynomials and polynomial equations. Ang focus natin ngayong araw ay tungkol sa division of polynomials, remainder theorem, factor theorem, at rational root theorem. Tara, samahan nyo ako na mag-review, mag-aral, at matuto. Simulan natin sa division algorithm. If p of x and d of x are polynomials and d of x is not equal to 0, there exists unique polynomials u of x, the quotient, and r of x, the remainder, such that the polynomial p of x is equal to the product of d of x, the divisor, times the quotient u of x plus the remainder r of x, where either r of x, the remainder, is equal to 0 or of degree less than d of x, the divisor. Ito ang unang example. Find u of x, the quotient, and r of x, the remainder, when the polynomial 3x raised to 4 plus x plus 2 is divided by x squared plus 1. Let us now have the solution for example number 1. We need to divide the polynomial 3x raised to 4 plus x plus 2 by x squared plus 1. For this example, we will use long division. Now, let us write our dividend and divisor. For our dividend, we have 3x raised to 4 plus 0x raised to 3 plus 0x squared plus x plus 2. So, we have completed the polynomial. We replace the missing terms by 0. And those are 0x raised to 3 and 0x squared. Then we have our divisor, x squared plus 1. Now we are ready to divide. We will continue dividing until we get a remainder that is equal to 0 or a polynomial that is degree less than the divisor. So in dividing polynomials, the first thing to do is to divide the first term of the dividend by the first term of the divisor. So 3x raised to 4 divided by x squared, and we will get 3x squared. And next, the quotient 3x squared will be multiplied by the divisor x squared plus 1. We will obtain 3x squared times x squared is 3x raised to 4. 3x squared times 1 is 3x squared. So that is positive. So we write plus sign. Don't forget to align like terms. Next is to subtract. So we will have 3x raised to 4 minus 3x raised to 4 is 0. 0x raised to 3 will be disregarded. Next, we have the difference of 0x squared minus 3x squared, that is negative 3x squared. Then we bring down the following terms. Now we have a new dividend, and the degree of the new dividend is in the second degree. the degree of the divisor is in the second degree, so they are equal, so we can still continue. So we repeat the process. We divide the first term of the dividend by the first term of the divisor. Negative 3x squared divided by x squared is 3 or negative 3. We now then multiply negative 3 by the divisor, x squared plus 1. And negative 3 times x squared is negative 3x squared. Negative 3 times 1 is negative 3. Again, we align like terms. Then we subtract. So the negative 3x squared will cancel out each other. Then we bring down x and get the difference of 2 minus negative 3. That is equal to 5. So we will have x plus 5. Now, next, as you all observe, the degree of the new dividend is in the first degree and it is less than the degree of the divisor. So we will stop the process. Hanggang doon na lang tayo. Now we can write our quotient u of x is 3x squared minus 3. Our remainder r of x is x plus 5. Then we write the algorithm, the division algorithm. P of x equals d of x times q of x plus r of x using the results. So we will have the polynomial 3x raised to 4 plus x plus 2 is equal to the product of the divisor x squared plus 1 times the quotient 3x squared minus 3 plus the remainder x plus 5. Sana nasundan ang proseso at naunawaan. Diretso na tayo sa sunod na theorem, the Remainder Theorem. If r is a number and the polynomial p of x is divided by x minus r, then the remainder is p of r, where p of r is the value of the polynomial x at r, or r is equal to p r. Here is an example. Find the remainder r when the polynomial p of x, 2x raised to 4 plus x raised to 3 minus x minus 12 is divided by x minus 2. Ito ang solution para sa example number 2. Ang una natin gagamitin ay ang long division. So we now write our dividend and divisor. Our dividend is 2x raised to 4 plus x raised to 3 plus 0x squared minus x minus 12. Again, we replace the missing term of the polynomial by 0. And that is 0x squared. We have our divisor, x minus 2. The degree of the dividend is in the fourth degree. And the degree of the divisor is in the first degree. Now we can divide. Let us start. Divide first term by first term. 2x raised to 4 divided by x. We will get 2x raised to 3. And the quotient multiplied by the divisor, we will get 2x raised to 3 times x is 2x raised to 4. 2x raised to 3 times negative 2 is negative 4x raised to 3. Now we subtract. 2x raised to 4 will cancel out each other. Then x raised to 3 minus negative 4x raised to 3. That is 5x raised to 3. And now we bring down the next terms. We now have a new dividend. Its degree is in the third degree, so we can still continue. Again, first term divided by first term, 5x cubed divided by x, we will have plus 5x squared. Then multiply the quotient by the divisor, we will get 5x squared times x is 5x cubed. 5x squared times negative 2 is negative 10x squared. We now get the difference. 5x raised to 3 will cancel out each other. The difference of 0x squared minus negative 10x squared is 10x squared. Bring down the next terms. We have a new dividend and its degree is in the second degree. The divisor is in the first degree. Let us still continue. First term divided by first term, 10x squared divided by x is plus 10x. The quotient times the divisor. 10x times x is 10x squared. 10x times negative 2 is negative 20x. We get the difference. 10x will cancel out each other. Negative x minus negative 20x. We have 19x. Then bring down the last term. We now have a new dividend and its degree is in the first degree, which is equal to the degree of the divisor, so we can still continue. Divide 19x by x, we will get plus 19. Then the quotient times the divisor, we will get 19 times x is 19x. 19 times negative 2 is negative 38. Then get the difference. 19x will cancel out each other. Negative 12 minus negative 38 is 26. 26 is a constant term, and that is a degree less than the divisor, so we will now stop the process. So our remainder is 26. Let us now use the remainder theorem. So the polynomial p of x is equal to 2x raised to 4 plus x raised to 3 minus x minus 12 will be divided by the divisor x minus 2, and let us compute for the remainder. We now equate the divisor x minus 2 to 0, and adding the additive inverse of negative 2 both sides, we will obtain x equals 2. We now then substitute x equals 2 to all x in the polynomial. So we will write p of 2 is equal to 2 times the quantity 2 raised to 4 plus 2 raised to 3 minus 2 minus 12. Evaluating this, we have p of 2 equals 2 times the quantity 16 plus 8 minus 14. 2 raised to 4 is 16. 2 raised to 3 is 8. Negative 2 minus 12 is negative 14. Let us continue. P of 2 is 2 times the quantity 16 minus 6. 8 minus 14 is 16 minus 6. Finally, p of 2 is 26. So the remainder, when the polynomial 2x raised to 4 plus x raised to 3 minus x minus 12 is divided by x minus 2, we will obtain a remainder 26. So if you are asked to find the remainder, you may use either of the two methods. Kung alin ang mas madali para sa inyo, pwede nyong gamitin. Sana naunawaan. Ito na tayo sa pangatlong theorem, the factor theorem. X minus r is a factor of the polynomial p of x if and only if p of r is equal to 0. X minus r is a factor of the polynomial if the polynomial p of x is divided by x minus r and we obtain 0 as remainder. Here is an example. Let us show that x plus 1 is a factor of the polynomial p of x is equal to 2x raised to 3 minus 4x squared minus 6x. Subukan natin. Para sa solution na ito, gagamit tayo ng synthetic division. I will guide you to divide a polynomial by x minus r using synthetic division. Ang una nating gagawin is to equate our divisor x plus 1 be equal to 0. Then we solve for x by adding the additive inverse of 1 to both sides of the equation. We will obtain x equals negative 1. Negative 1 will be our divisor using synthetic division. Sunod, we need to complete the polynomial. So we replace the missing term or terms of the polynomial by 0. In this case, the missing term of the polynomial is the constant. So we will add 0 as the constant. And we need to arrange the polynomial in descending order with respect to the exponent. So we have completed the polynomial and we have arranged the polynomial in descending order. Ito ang susunod nyong gagawin. We will list the numerical coefficient of each term. The numerical coefficients are 2, negative 4, negative 6, and the constant term 0. Then we write our divisor. Our divisor is negative 1. So now we are ready to divide using synthetic division. So you need to bring down the first coefficient, that is 2. So we bring down 2. Then we multiply 2 by negative 1 and we place it under the second coefficient. Negative 2 is the product of 2 times negative 1. We now then add negative 4 times negative 2. We will get negative 6. Then we repeat the process, multiplying negative 6 by negative 1. The answer is 6. We place it under the third coefficient. Then we add negative 6 plus 6. is 0. Then, multiply again 0 by -1, and we will get 0. We place it under the constant term, and we get the sum. And the sum is 0. So, by synthetic division, since our remainder is 0, we have shown that x plus 1 is a factor of the polynomial 2x raised to 3 minus 4x squared minus 6x. Now, let us use the remainder theorem. If we will obtain a remainder of 0, then x plus 1 is a factor of the given polynomial 2x raised to 3 minus 4x squared minus 6x. So we write the polynomial and our divisor x plus 1. Then we equate that to 0. And we solve for x by adding the additive inverse of 1 to both sides of the equation. We will obtain x equals -1. Similar with the synthetic division. So we now then substitute x equals -1 to all x in the polynomial. So we write p of -1 is equal to 2 times -1 raised to 3 minus the product of 4 times the quantity -1 raised to 2 minus the product of 6 times -1. We evaluate. P of -1 is equal to 2 times -1. -1 raised to 3 is still -1 minus the product of 4 times 1. -1 squared is 1 plus the product of -6 and -1 is 6. To continue, we will have p of -1 is equal to -2, the product of 2 and -1, minus 4, the product of -4 and 1, plus 6. And finally, we will obtain p of -1 equals 0. -2 minus 4 is -6 plus 6, 0. So we have shown that x plus 1 is a factor of the polynomial p of x equals 2x raised to 3 minus 4x squared minus 6x. We obtain a remainder of 0 to both synthetic division and in remainder theorem. So finally, we can write x plus 1 is a factor of the polynomial 2x raised to 3 minus 4x squared minus 6x, since in the remainder theorem, p of -1 is equal to the remainder in the synthetic division, and the remainder is 0. Nasa pang-apat at panghuling theorem na tayo, the rational root theorem. Let p of x equals a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus a sub 1 x plus a sub 0 be a polynomial with integer coefficients. If p over q is a rational number in lowest terms and is a 0 of the polynomial p of x, then q is a factor of a sub n and p is a factor of a sub 0. Subukan natin ito with example number 4. Letter A, find all the possible rational zeros of the polynomial p of x equals x raised to 3 minus x squared minus 4x plus 4. Letter B, find all the roots of the polynomial. Letter C, find all the factors of the polynomial. Tara, gawin na natin. For the solution in letter A, let us find all the possible rational zeros of the polynomial. By rational root theorem, a sub 0 or the constant is equal to 4. And a sub n, the numerical coefficient of the leading term, x raised to 3 is equal to 1. Now, p is the factors of the constant term. That is 4. So we will list all the factors of 4. So we have the first factor is 4 because 4 times 1 is 4. The second factor is negative 4 because negative 4 times negative 1 is equal to 4. We also have 2. 2 times 2 is 4. Then we have negative 2 because negative 2 times negative 2 is 4. And 1 because 1 times 4 is 4. And negative 1 because negative 1 times negative 4 is 4. So we are done listing the factors of the constant term. Now, let us list the factors of the numerical coefficient of the leading term. And that is 1. So, Q is the factors of the leading coefficient. Factors of 1 are first 1. 1 times 1 is 1. And we have negative 1. Negative 1 times negative 1 is 1. Next, we will get the ratio of the factors of the constant and the factors of the leading coefficient. So we will start with the ratio of 4 and 1. 4 over 1 is 4. Next, the ratio of 4 and negative 1. 4 over negative 1 is negative 4. Now, we get the ratio of negative 4 and 1. That is negative 4. Naisulat na natin. The ratio of negative 4 and negative 1. That is 4. Naisulat na rin natin. Next, the ratio of 2 and 1. 2 over 1 is 2. The ratio of 2 and negative 1. 2 over negative 1 is negative 2. The ratio of negative 2 and 1. Negative 2 over 1 is negative 2. Naisulat na rin natin. Negative 2 over negative 1 is 2. Meron na din. And finally, the ratio of 1 and 1. 1 over 1 is 1. The ratio of 1 and negative 1. 1 over negative 1 is negative 1. And The ratio of negative 1 and 1 is negative 1. The ratio of negative 1 and negative 1 is 1. Tapos na tayo sa listing of possible rational zeros of the polynomial. So, the possible rational zeros of the polynomial are 4, negative 4, 2, negative 2, 1, and negative 1. Subukan naman natin ang letter B. Find all roots of the polynomial. First, I will show you again the possible rational zeros of the polynomial. In letter B, we will use synthetic division to find all the roots of the polynomial. We will use the possible rational zeros as our divisor in synthetic division. And if we obtain a remainder equal to 0, then the divisor is a root of the polynomial. And by the way, the degree of the polynomial determines the number of roots it has. Since the degree of the polynomial is in the third degree, we will be looking for 3 roots of the polynomial. So, gawin na natin. Kagaya kanina, we will list the numerical coefficients of each terms of the polynomial. And now, I will choose one possible rational zeros from letter A as my divisor. So, ang una kong pipiliin ay 1. So, let us start. We bring down the first coefficient. That is 1. We multiply 1 by the divisor. 1 times 1 is 1. We write it under the second coefficient. And we add negative 1 plus 1 is 0. We repeat the process. 0 times 1 is 0. We write that under the third coefficient. And then we add negative 4 plus 0 is negative 4. Then multiply negative 4 by 1. We will get negative 4. Then add 4 plus negative 4, 0. So we obtain a remainder which is equal to 0. Therefore, 1 is a root of the polynomial. So we will now disregard the remainder and we will write the depressed equation. The depressed equation is an equation which is 1 degree less than the given polynomial. So, the given polynomial is in the third degree, so meaning the depressed equation is in the second degree. And we will use these quantities as the numerical coefficients of the depressed equation. So we have x squared 1x squared plus 0x minus 4. Let us now find the second root of the polynomial and we will use the depressed equation. Again, I will choose one possible rational zeros of the polynomial from letter A. I will choose 2. Now I will proceed. Again, we bring down the first coefficient, then multiply it by the divisor. 1 times 2 is then we add 0 plus 2. We have 2. Multiply 2 by the divisor. 2 times 2 is 4. Then we add negative 4 plus 4, 0. So again, we obtain 0 remainder. Therefore, our divisor 2 is a root of the given polynomial. So again, we disregard the remainder and we write the depressed equation. That is 1 degree less than the given polynomial. So this is in the second degree. So the depressed equation is in the first degree. So we will use these quantities as our coefficient. So we will write 1x plus 2. So isa na lang ang hahanapin natin na root of the given polynomial. Pipili uli ako sa letter A. Pipiliin kong pangatlo ay susubukan ko ang negative. I will now proceed. I will bring down the first coefficient 1, then multiply it by the divisor. 1 times negative 2 is negative 2. We add 2 and negative 2, and we obtain 0 as remainder. So, negative 2 is a root of the given polynomial. So, we have the roots of the given polynomial, x raised to 3 minus x squared minus 4x plus 4. The roots of the polynomial are x equals negative 2, x equals 1, and x equals 2. Ngayon, sagutan naman natin ang letter C. Find all the factors of the polynomial. Again, here are the results in letter A and letter B. Here is the solution for letter C. Just transform the roots into the form x minus r equals 0. So here we have the roots of the polynomials. Just transform this into the form x minus r equals 0. So we will start with x equals negative 2. We add the additive inverse of negative 2 to both sides of the equation, and we will get x plus 2 equals 0. Next, x equals 1. We transform this into x minus r equals 0 by adding the additive inverse of 1 to both sides of the equation, and we will get x minus 1 equals 0. Finally, x equals 2. We will obtain x minus 2 equals 0. A while ago, we have verified that x plus 2, x minus 1, and x minus 2 by synthetic division will give us 0 remainder. And by factor theorem, we can say that the polynomial x raised to 3 minus x squared minus 4x plus x is equal to the product of the factors x minus 2 times the quantity x minus 1 times the quantity x plus 2. And that ends our discussion. Sana ay naintindihan ninyo ang bawat computations at mas naunawaan ang inyong lesson. Maraming salamat sa inyong panonood at pakikinig sa ating video. Nawa ay natulungan ko kayo at nagabayan upang mas maintindihan nyo ang inyong lesson. Gusto ko ring magpasalamat sa mga sumuporta sa ating YouTube channel at sa ating Facebook page. Shout out sa inyong lahat. Hindi ko kayo may isa-isa dahil sa dami. Pero taos puso akong nagpapasalamat sa inyo at sa inyong suporta. Hanggang sa muli, ako ang inyong teacher, si Teacher Royce. At magkita-kita tayo sa susunod na video. Maraming salamat. Paalam!